lecture, I'm going to discuss problems on directional derivative and gradients of a scalar function. So let us take a first problem. So find the derivative of the function x cube minus xy square minus z at the point p naught is equal to 1, 1, comma 0 in the direction of v 2i minus 3j plus 6k. So in what directions does change most rapidly at the point p naught, where p naught is equal to 1, 1, 0, and what are the rates of change in these directions? Move to solution. Given f is equal to x cube minus x into y square minus z at the point p naught is equal to 1 comma 1 comma 0. So let us find out the gradient of f, where f is the functions of three independent variable. We have gradient of f can be written as, so dou f by dou x into I cap plus dou f by dou y into j cap plus dou f by dou z into k cap. So differentiate f with respect to x, y and z partially. So we get dou f by dou x is equal to differentiation of x cube is 3x square minus differentiation of x, y square is constant here, differentiation of x is 1, y square constant return, minus differentiation of z, that is 0, because while differentiating with respect to x partially, other variables y and z are the constants. So now we find out dou f by dou x at the point p naught, where p naught is equal to 1, 1, 0. So with 3 is x is equal to 1 here, 3 into 1 square minus where y is 1, 1 square, so that is equal to 2. So let us find out dou f by dou y. So differentiate f with respect to y partially, treating x and z are the constant. So differentiation of x is 0 minus x into 2y minus 0. So dou f by dou z, dou y at the point p naught, so that is equal to, where x is 1, so minus 1 into 2 where y is 1, so that is equal to minus 2. So differentiate f partially with respect to z, treating x and y are the constant, differentiation of x cube and minus xy square, that is 0, minus 1, differentiation of z is 1. So dou f by dou z at the point p naught, so that is equal to minus 1. So therefore gradient of f, so that is equal to 2 I cap, where dou f by dou x is 2, minus 2 j cap, where dou f by dou y is minus 2 and dou f by dou z is minus 1, minus 1 into k cap. So this is the gradient of f at the point p naught, where p naught is equal to, so 1 comma 1 comma 0. So now we'll find out the unit vector. To find unit vector, so given v is equal to, vector v is equal to 2i minus 3j plus 6k. So where unit vector of vector v is equal to vector v by modulus of v. So where modulus of v, vector v is equal to square root of, so ith component 2 square plus jth component minus 3 whole square plus kth component is 6 square. So that is equal to square root of 49 so that is 7. So therefore unit vector u is equal to 1 by 7 into 2I minus 3j plus 6k. So this is the unit vector. Now let us find out the directional derivative. The directional derivative of the function f in the direction unit vector u at the point p naught. So that is equal to gradient of f dot unit vector u. So where gradient of f is equal to here, so that is 2i minus 2j 2i minus 2j minus k dot product, where unit vector u is equal to 1 by 7 into 2i minus 3j plus 6k. So this can be written as 1 by 7 into 2 into 2 4, I dot I is 1, minus into minus plus 2 into 3 6, j dot j is 1, minus into plus minus, so 1 into 6 6, k dot k is 1. So 1 by 7, 6 minus 6 get cancel into 4, so that is 4 by 7. 4 by 7 is a scalar quantity, so it is a direction derivative of the function f in the direction of unit vector u at the point p naught. So next you have to find out the where the function increases most rapidly, in which direction you have to find out. Already you have seen that what is the gradient of f. So where the gradient of f is equal to 2i minus 2j minus k. So therefore the function f increases most rapidly in the direction of 2i minus 2j minus 1 into k. So let us move to solution. The function f increases most rapidly in the direction of gradient of f. So where gradient of f is equal to 2i minus 2j minus k, and the function f decreases most rapidly in the direction of minus gradient of f. So that is equal to minus of 2i minus 2j minus k. So that can be written as minus 2i plus 2j plus k. Modulus of gradient of f, so that is equal to square root of 2 square plus minus 2 whole square plus minus 1 whole square. So that can be written as square root of 9, so that is equal to 3. Where 3, the rate of change of the function f increases rapidly in the direction of gradient of f, and minus modulus of gradient of f is equal to minus 3. So this is the rate of change of the function f decreases most rapidly in the direction of minus of gradient of. The algebra rules for the gradients. Let f and g be two differentiable scalar functions. Gradient of k into f, so that can be written as k into gradient of f, where k is constant. It is called constant multiple rule. So gradient of f plus g, so that can be written as gradient of f plus gradient of g is called sum rule. Third one, gradient of f minus g, difference of two scalar function. Gradient of f minus g is gradient of f minus gradient of g, we can write. This is the difference rule. Gradient of product of two scalar function f into g, so that can be written as f into gradient of g plus g into gradient of f. This is a product rule. If there are gradient of two product of two functions, so that can be written as first function into gradient of second function plus second function into gradient of first function. Gradient of f by g, division of two scalar function, gradient of division of two scalar function f on g, so that is equal to g into denominator gradient of f minus f into gradient of the denominator divided by g whole square is a quotient rule. Provided g should not be a zero scalar function. So these are the algebraic properties of the gradients. Let us take an example. Let f is equal to x minus y and g is equal to 3y. So f is a function of x1 and g is also a function of x and y. So that is equal to g is a function of x and y. Now, so what is the gradient of f here? Gradient of f is equal to dou f by dou x into I cap plus dou f by dou y into j cap. So that can be written as 1i minus 1 into j. So gradient of g is equal to dou f by dou x into I cap plus dou f by dou y into j cap. So that is 0i because there is no x term here, and plus 3 into j cap. So then we can find out gradient of 2f. So gradient of 2f can be written as 2 into gradient of f, according to property of algebra for the gradients. So that is 2 into gradient of f is I minus j. Yes. So that is equal to 2 into gradient of f. Yes. Now the first point. Second point here, gradient of f plus g. F plus g is equal to, that is gradient of, what is the gradient of f here? F is x minus y plus 3y. So that can be written as gradient of what? X plus 2y. So gradient of x plus 2y is, you can write dou f by dou x, that is I cap plus 2 into what? j cap. So what is the gradient of f plus gradient of g here? Gradient of f is I minus j plus gradient of g is 0 plus 0 I plus 3 into j cap. So that is I minus I plus 0 I cap is I cap minus j plus 3j minus plus 2j. Yes, this is true. We can write as therefore we can write gradient of f plus g can be written as gradient of f plus gradient of g. Now gradient of f minus g, so that is equal to gradient of where f is x minus 5 and minus of g where g is 3y, that is x minus y minus 3y minus 4y. So gradient of this function is dou f by dou x is where x differential 1, that is I cap minus 4 into j cap. So this can be written as, so I minus j minus 3j, where I minus j is a gradient of f, so that is gradient of f minus where 3j is gradient of g, that is minus gradient of g. Therefore you can write gradient of f minus g can be written as gradient of f minus gradient of g. So let us take the gradient of multiplication of two function. So that is gradient of f into g, gradient of where x is x minus y into 3y. So that can be written as gradient of that is 3xy minus 3y square, 3y square. So this is equal to 3y I cap, adding and subtracting 3y j cap, subtracting 3y j cap plus adding 3y j cap plus 3x 3x minus 6y into j cap. So this can be written as, so if I take 3y common, I minus j cap, 3y into j cap minus 6y into j cap. So that can be written as 3x minus 3y into j cap. So this can be written as 3y into I minus j plus, here if I take 3 common, that is x minus y into j cap. So where 3y can be written as g, I minus j cap is gradient of f plus x minus y, where x minus y is function f here, f, and with 3 into j cap is gradient of g. So therefore you can write gradient of fg can be written as g into gradient of f plus f into gradient of g. So let us take same example with division of two scalar functions. Gradient of f by g can be written as, so gradient of where f is x minus y by g is 3y. So this can be written as, so gradient of x by 3y minus 1 by 3. So gradient of x by 3y minus 1 by 3 can be written as, so where gradient of this function is dou f by dou x, x differential 1 by 3y into I cap, then so then dou f by dou y, differentiate this function with respect to y, 1 by y differential minus 1 by y square, that is minus x by 3 into y square into j cap. So this is the gradient of the function x by 3y minus 1 by 3. Now take it LCM. 3y square is the LCM. Here yi minus x into j. So this can be written as 3y into I cap minus 3x into j cap by 9y square. So this can be written as this is equal to 3yi minus 3yj plus 3yj added and subtracted 3yj minus 3xj by 9y square. So this can be written as 3y is common into I minus j. Here let us take minus common, minus 3 common. If we take minus 3 common, x minus y into j divided by 9y square. So this can be written as where 3y is g, where I minus j is the gradient of f minus x minus y is f here. 3 into j is gradient of g by, so g whole square. Therefore we can write gradient of f by g is equal to g into gradient of f minus f into gradient of g by g whole square. So take another example. Find the gradient of f where f is a function of x and y. So that is y into log x plus x into y square. So we'll move to solution. We have gradient of a scalar function f can be written as dou f by dou x into I cap plus dou f by dou y into j cap. So here f is y into log x plus x into y square. Differentiate f with respect to x. So y is constant, log x differentiation 1 by x plus y square is constant, x differentiation 1. So similarly find out dou f by dou y. So here log x is constant, y differentiation 1 plus x is constant, 2y square differentiation 2y. So therefore gradient of f is equal to where dou f by dou x is y by x plus y square into I cap plus where dou f by dou y is log x plus 2xy into j cap. So this is the gradient of a scalar function f. So find the directional derivative of the function f at the point 1 minus 1 comma 2 in the direction of u, where u is equal to 3i plus 6j minus 2k, and where f is equal to xy plus yz plus zx. So let us move to the solution. Given function f is equal to xy plus yz plus zx at the point p naught, that is 1 comma minus 1 comma 2. So let us find out the gradient of f. So gradient of f is equal to dou f by dou x plus I cap plus dou f by dou y into j cap plus dou f by dou z into k cap. So where dou f by dou x is differentiate function f with respect to x. So x differentiation, that is 1 into y. Here y, but here you have x, then y plus z into I cap. With respect to y, if we differentiate x plus z, x plus z into j cap. With respect to z, if we differentiate, we have x plus y into k cap. Let us find out gradient of f at the point p naught, where p naught is equal to 1 comma minus 1 comma 2, where y is -1 and z is 2, that is I cap. So x plus z, where x is 1 and y is 2, that is 3 into j cap, plus where x is 1 and y is -1, that is 0 into k cap. So now let us find out the unit vector u. So given vector u, that is equal to 3i plus 6j minus 2k. So unit vector u can be written as vector u by magnitude of u. So where magnitude of u can be written as square root of 3 square 9 plus 6 square 36 plus minus 2 whole square plus 4. So that is equal to square root of 49. So that can be written as 7. So therefore u cap, unit vector u cap can be written as 1 by 7 into 3i plus 6 3i plus 6j minus 2k. Okay. So 3i plus 6j, this is okay. So therefore directional derivative of the function f in the direction u at the point p naught can be written as gradient of f into unit vector u. So where gradient of f is I plus 3j plus 0 into k cap dot product of 1 by 7 into 3i plus 6j minus 2k. So this is equal to I dot I is 1. So 1 into 3, that is 3. The 1 by 7, take it outside, 3. Then 3 into 6, 18. J dot j is 1 and k dot k is 1 and 0 into minus 2, that is 0. So 21 by 7, that is equal to, so 3 is a scalar quantity.